Yeah, welcome, people joining. I'm really excited about this one to have Wolfgang Piatke directly from Hundegger tell us about the world of CNC machines. And I invited Stefan Schneider, my business partner, because he works with them all the time. But I'll start the event with having Wolfgang give his background and then enter his presentation. And we will make a couple of pauses during the presentation to take questions, but not too many questions because we want to make sure he has time to get through the presentation. So Wolfgang, can you test with your screen share? That's working. And then
I think it is.
There it is. Perfect. Okay, so please take it away, Wolfgang.
Okay, so hello everybody. Nice that you attend our session here for 1 hour. I'm Wolfgang. I'm with Hundegger for more than 20 years now, and from my basic background, I was working in the building industry as a youngster because school was not so interesting for me. But then I decided, okay, to finish school, later went to university, but during that time I still continued to work on the construction sites because it was unbelievable money for a young guy. Later on, I had the chance to work in an automotive industry area as a trainee manager, export manager. And so I ended up when Hans Hundegger was seeking for a person to build up his export department in the 2000s. It was about 2000 or 99. And so I joined Hundegger. And from this time, I was always working in the export countries, North America, Asia, South America, Scandinavia. These are my main markets where I work on. And so I was very early aware about the trend with the CLT, with GLT, with all the possibilities. And we think Hundegger is for sure one part of this of GLT and CLT because we are only producing machines for processing structural components. It could be very small components from 2x4 up to massive glue lamp structures with 50 meters and span, curved, whatever. So we have solutions for different tasks, for different products. And today I want to show you a little bit, okay, what can we do with mass timber? Mass timber in North America is a little bit like a religion, in my opinion, and a religion that is growing very rapidly. But the roots are still in the timber design, in the structures, in the design of wooden buildings, wooden structures. And we built machines from the very beginning. For the last 40 years, we built them. And currently we do a turnover of about 110 million euros per year, close to 500 employees. All of them are working in this really nice factory, which is more or less completely built from timber. So even all our production buildings are made from timber, even the office building here and the training center on the right side is there. The right side building, this is only for training. Training and testing and new developments are very important. So we decided to build a complete part only for this purpose. And I think currently, although we have COVID also a little bit, but we are not affected that much, per week, there are minimum 10, 12 companies in-house for training on their machines that they will receive because it's important. You buy an expensive machine and it should work. And that leads us straight to what we want to present, or what I want to present to you today. It's CNC machine for mass timber. Okay, so first of all, a little bit theoretical part, how to classify mass timber CNC machines. You can classify them by product. You say you have machines for beam processing, and the beams could be straight or curved. You have machines for panel processing like CLT, SIP panels, or whatever. You can classify them by the process. So the machine that move the materials, the machine will move the material through the machine to the different aggregates and stations, or you have machines that move over the material like gantry machines. So the panel is fixed on a table and the machine will run over it and cut out all window, door openings and whatever. But you can even classify by the different processing concepts of these machines. There are machines that use a tool changer system. So you have one big spindle that will select different tools. And will perform the operations on the beam or on the panel. Then you have systems where you have fixed aggregates, spindles with fixed tooling. This will allow you a higher capacity because you have a specialized aggregate specifically for that purpose, maybe a big saw blade for slotting big beams, or drills that can drill 600 millimeter deep into the timber. Or you have a combination of both. You can combine even tool changer systems with fixed aggregates, which gives you almost unlimited possibilities or unlimited flexibility. For all these kinds of machines or these purpose and demands, we have the right machine. It starts with a TD2, which is a very small machine, up to the K2 industry for the biggest beams, where you can handle beams up to 460 millimeter in height and with 1300 millimeter. Maybe Stefan can later translate it a little bit in inches and feet, what we can do in the cross sections, because then it's a little bit easier by you.
18-inch by about 4 feet width, so 1250 would be 48-inch-ish.
Perfect. And when we go for straight curved beams, the dimensions could even be much larger. It could be this 4 feet by 430 millimeter and the length up to 50 meters. So this is then only the limit is, let's say, the investment and the space that is available for the customers. And here we go straight on into what we can offer. So this would be a perfect setup. If you like to produce mass timber components, that would be a great setup. On the right side, you have a B machine. That's here a K2 machine. And on the left side, you have a PDA machine to work on CLT panels or on large glue lamps, laminated beams. You can see this building is a customer in Germany. It's called CLT Gottschalk. They are doing any kind of wooden structure. And the wooden structure, mass timber, is here also building production buildings, buildings for storage, for forwarding companies, commercial buildings. This is a huge part of mass timber in Europe, which maybe swap also in the future to North America if you have the right timber available. Big advantage still in Germany is you order the right cross section in the right length, and you can select from 4 or 5 suppliers. They will deliver you perfect quality in time. This is really a big advantage for our clients, because only a minority of clients are from timber industry, like the big sawmills. And that will later on be a part, because the trend in the CLT is the sawmill industry. They are investing in this product because it's a mass product. It's a commodity product where they are used to work in like the big 2x4, 2x6 sawmills in North America. They are very strong because they're only doing that. And here in Germany, you will hardly find a company that is doing CLT panels and is going to buy all the lamellas, because their sawmill, they can source it and they can use the not perfect timber for the middle layers, which is the winning part of this game. Okay, robot drive can do almost everything because it's a machine where you change the tools. You can see now the layout, I think. You see the layout, Stefan?
Yeah, not the layout.
Yeah,
no, we see the photo. There it comes. Yeah, there is a floor plan view of that.
Okay, so the robot drive has a reasonable size. So the machining area is only about 3 meters, where the rest could be used for in-feed and out-feed. And here we can handle beams up length 30 meters, but we have also customers, they go for lengths up to 20 meters with the machine. Here you have a photo where you see the machine installed in a very simple workshop. So this machine is used from carpenters up to glue lamp factories to everybody, because the reason is due to the flexibility, which is caused by only changing the tool. You can do almost everything with the machine, from lockhouse construction up to nice trusses from glue lamps, whatever. You can make dovetail connections. Everything is possible. Stefan, you see now the picture where the machine is installed?
I do. Maybe quick gap for those that are not familiar with Hundegger machine. So the wood moves from the left to the right. So on the left-hand side, where you see the long beams, that's the in-feed, runs through the processing center and then comes out on the right side. And I think you can special order one backwards, but that's sort of the workflow for all Hundegger machines.
And this is good to add on. The idea is already, you see the very long timber at the infeed. This part could already be nested in the office. So depending on what you want to produce, you make your project file, you make your nesting, and then you can tell your supplier, okay, I need a specific length of beams. And later on, the operator here, he already knows what he should cut out of this beam. And necessarily, he has not to select that again. This is already stored and done in the office. So the operator is really operating the machine and not programming the machine. Programming happens in the office. This is the key to success. You cannot do that at the machine. That would waste too much time. Okay, so we have here detailed pictures of infeed and outfeed area. And here you can see now the spindle. You see the spindle is using once time on the right picture, a big milling head. And on the left picture, we have a finger mill. Depending on what operation the machine has to carry out, it can work from all 6 sides on the timber without turning the timber. So we can also make lengthwise operation, as you can see in the right pictures. That will be a hip rafter by the end. And on the left side, we have a little bit of this timber frame stuff. This would be a video which would not work in PDF, but it doesn't matter. Here we see a very big spindle working on a CLT panel, on a smaller CLT panel, and it's just cutting out a service hole into the CLT panel. So you can do from beams to CLT panels, smaller sizes, everything on the robot. It's just a matter of tooling. Also drilling, because if we talk about GLT, we have very often metal connectors that have been connected to the timber. And how do I connect a metal connector? I do it with a bolt and a metal part. And for this, I need drills and slots. In the next picture, you can see this very long drill that is going in face end side, where we can go with the robot here more than 400 millimeter deep. And already we have performed a very nice slot where you can later on assemble your metal plate. This would, again, a video that would show the drilling cycle, but unfortunately this will not work here in the PDF file.
So that's about 15 inch, right? Your 400 millimeter for the inch people here.
Yep, thank you. We have now the picture with the slot cutter. You see that, Stefan?
Yeah.
Yep. The slot cutter is a tool that can do slots in any angle, any position, but it's limited because greasing is an issue. It will become hot by the time. So if you make a lot of slots, it's necessary, in our opinion, to have an additional spindle. We have the possibility to have in the robot an additional spindle where we can attach a big saw blade with a diameter of 800 millimeter. This saw blade enables you to make face end slots or slots alongside the timber very efficiently and very quick and very clean. So this is an additional aggregate that could be added on even later on our machine, and that will even give you capacity because every part has at least 2 sockets, front side, rear side. And for this purpose, we don't have to change the tool. So we can move the timber in, cut it, process it, take it out. So we minimize the amount of tool changes, and that will give you capacity. So what we have also here, we have different tools available. We have a tool rack with 16 different spots available. Additionally, we have a tool rack where we can have the slot cutter, and we can even have special aggregates as like this multi-drill head to where we can perform a drill pattern. This could be for metal plate connectors or for acoustic reasons, acoustic elements. So the idea of a tool changer machine is to use the flexibility to improve your product and to make the work easier for you by using the right tool. This would be a video showing the saw cutting out a lengthwise cut with pre-cutting, because cutting is sometimes quicker than milling. Milling takes time because you generate a lot of shavings, it's less sawdust, and it's even less wear out on tooling because a saw blade has to be resharpened. If you have a cutter head, you need new cutters, or you have to resharpen the cutter, which is more expensive. Okay. This was a small glance about the robot drive, I'm more than happy to answer later questions or even to show a video after this presentation online, because this is now PDF and unfortunately not interactive. Good.
Yeah.
The next. Yep.
Go ahead. Do you want to answer some questions now, or do you want to keep going?
Why don't you do the K2 and then maybe we can kind of do questions. And I think that's a question I get a lot. It's like, well, what is the K2 better? Is the robot drive better? And kind of, there's two products essentially doing the same thing with a very different approach. And then maybe, if you show both machines, maybe we can kind of talk about that briefly and take questions.
Yep, good. So the K2 is the next machine for Glulam's GLT. And the idea is the same. We have on the left side, we have our loading conveyor where we load the material, we move it through the machine. And in the machine, we have different kind of aggregates to perform different operations. And on the right side, we feed out again the individual components. Again, there's a nesting function. So one raw material beam could consist of several finished parts. Cross sections could also be very, very large, up to 4 feet in width and 460 in height. So this is very big columns where you can use the K2 industry also. So this would be a video, unfortunately not working, but not a problem. So this machine, the K2, consists of different aggregates and spindles. One of the main aggregates is the saw unit, which can cut 300 millimeter in one stroke. If it comes to a bigger cross section, then we have to turn the timber, or we have to use an integrated robot aggregate that would mill or cut the beam from the top side. So we can go 300 here from one side, we can rotate 360 degrees in an angle, and we can even inclinate to the saw blade to perform a compound cut. So besides the saw unit, the next unit what we have installed there is a very powerful milling head. It's called universal milling unit, which could be upgraded with a water-cooled spindle up to 35 kilowatt, which is, in my opinion, a little bit overpowered, but we have some guys, they like it. So it's not too bad to have power. As a standard, it already has 15 kilowatts. It's a direct drive here on the spindle. It's a 5-axis movement. So we can even work on a component cut rectangular to that. So this is the world famous dovetail connections on a jack rafter, would be connected to a hip and valley rafter without metal plate. But that depends if you really need this. What we also need for GLT, CLT in the context of mass timber is slotting, what I mentioned. And with the K2, we have different options for slotting. We have, for instance, the possibility to have chain slotters. They work from operator side or from fence side. And with these chain slotters, we can slot through the complete beam. But the chainsaw is only as good as the chain is. And the wear out is if you do a lot of beams, wear out is tremendous. For that reason, we developed a big horizontal saw blade to do these saw cuts in this position to make the slots for metal plate connectors, where you can then link glue lamps with metal posts, with concrete posts, whatever, just to put it in. And the saw blade diameter could be up to 1 meter, so we can go in here 400 millimeters from all 4 sides, which is very often enough. But if there's remaining timber, then we use the chain slotter, which is then much less wear out on these aggregates. But if we talk about these big cross sections, it's not only the metal plate connectors, it's also the dowels and screws we have to put in. And in the K2, we have the possibility to have a system where we work from bottom side and from top side the same time. So we drill simultaneously from top and bottom, which gives you a perfect result in the way of splinter-free operations. And also it's very quick because we can go in from top and from bottom very quickly and perform this drill hole very efficiently. Because you see here this glue lamp. There's sometimes glue lamps, they are up to 80 to 100 drill holes per part. And this is even always the answer then, yeah, how about accuracy? Because the machine can work very accurate, because you can imagine if one of these will not fit, it's very difficult to press in all the other dowels. This is very difficult. So your drill has to fit more or less 100%, otherwise you are lost. And even if you fix this then later at the construction site together, and you have the part that should fit here, also the opposite part has to fit 100%. Good. We talked about drilling, and sometimes there is the need for to do a deep drilling. That means operator side to bring in steel rods to have special connectors. Like in Switzerland, they have these GSA connectors where you connect beams, very long beams. You split into smaller beams and reconnect them again by a special metal rod connection. And for that purpose, you need special drills. Here we have a maximum drill length of 1250 millimeters, but then it's also a matter of the tool that you use, that you get a drill hole which is not diving up or diving down. Yeah, and what will you do from that? That is the very famous parts what we have here with this Baubuche, where Baubuche is similar to LVL, very hard to process. You need very good tooling. Here it's very good if you have a robot aggregate or a robot machine, because there you can adjust the RPMs of the tool specifically to the product. The other is with the robot, you can define your own strategies for different material, for different approaches. You can define a strategy for quality, so nice and tidy, or quick and dirty, more or less. If you don't get too much money from your customer and splintering don't care, then you work very quick and splintering. But for projects like this, where you combine modern technologies, metal plates plus traditional joinery, you want to have more or less like similar to furniture quality, and you can adjust this.
Maybe real quick, for I think most people here don't know what Baubuche is. So those are hardwood LVLs. That's where we use LVLs, that's mostly like fir and softwood. So these beams are incredibly hard and heavy, and that causes some challenges on the machining. And so what he's saying, that we can, it can adapt the machine to the hardness and the weight of the material, and then it would machine all different.
Yep.
That's not easy. That's for everybody that ever processed hardwoods. That's not easy to do. It's really hard on those tools.
Yep. And you can even see in this picture, there's even a running track later on where a crane runs, where even some carpenters or let's say some more they use this material because it's very stiff. I think it's GL80, up to GL80, and you can make very slim structures with architectural approach. So this is the idea. And when we talk about beams, what will we do with these beams? This is, in my opinion, a perfect approach for any kind of wooden processing company. This is a company in Belgium. It's called, or Luxembourg, it's called Ligna Systems. They are only building these kind of types of buildings. They have specialized. And you can see here the crane is running on such a beam made of Baubuche. So even the cranes are running on timber these days. This is possible. This is not an issue. This is a nice truss, featured truss made from softwood. And then they put in the necessary strength by this Baubuche. Yeah, this was the part for beam machines, unfortunately without videos, but if there are questions, I'm more than happy to answer questions regarding the beam machines. If there is something missing, there's a lot missing, because we are specialized in this machine and we have aggregates for almost every purpose, and we have a good ear on the market. So if there is a customer, hey, I have to do 30 drill holes in a drill pattern very specially. Maybe we can do an aggregate for that to improve your product, to increase your capacity.
Stefan, could you read through some of the questions on the Q&A, because you're answering them as well? Then
sure, yeah. Get that. There's the chat and the Q&A. Also, just maybe an FYI. If it's too bad we couldn't see those videos, but if you're interested, there's a lot of those machines and units or aggregates, like he calls it, on YouTube. I think on the Hundegger website, you'll find some of those as well. So if you're really interested, that's something you could, kind of dig in, and that's easy to find. So question first, what type of training you need to use a CNC in production lines? Are there specific trainings for manufacturing and side assembly of mass timber? Wolfgang, maybe you tell me if you want to answer the questions, and if you prefer me to do it, I can maybe give my 2 cents.
I think training, the major topic, you have to different a little bit the machine operator and the people in the office that do the preparation work for the machine. You have to be aware in the office, the machine has limitations. We can do maybe 98% or 95% very efficiently, 3% with a lot of work, and the last 2% are still manual work. So training the operator, if you have a skilled guy, a little bit aware about timber, smart, not afraid about of computers, if he works for 1 week with a skilled person, or maybe he can attend our training, he can operate a Hundegger. It's not magic. The person in the office who is doing the design work, and he has a good knowledge about design and his software package, if it's CAD work, HSB, CAD, Dietrich, whatever, he has adjusted his post-processor export. It's also very fine. By the time they will learn, okay, the machine has a limitation, but we'll find a roundabout. We find a workaround for that. So training is not magic. A smart guy, even if he's an electrician or a mechanic, smart mechanic can operate our machine if he's willing to do.
Yeah, and then maybe on the training end, especially for the US, so there is more schools now that have those machines there too. And from a user point of view, I would agree with that. Like 80% of the brain work and the difficult stuff really happens in the office. If it's designed really well, if it's planned really well, that the machine run the shop will be a lot easier, to a point where it's really just a couple buttons to push. It's not, there's not that much brain work at the machine anymore. Not that you don't need your brain at all, but it's all that stuff should be, prepped before. And that kind of maybe leads us to the next questions. Do we apply BTL files? So BTL is basically a CNC code file for those machines. Bautile language, I think it's called. Maybe I'll let you answer that real quick too. And then,
so we can import BTL files. That's not a topic. We also have our own format, the BVX2 file, and the BVX2 file gives you more depth of information. When we get a BTL, then we have a little bit of dialogue to where we have to start. Okay, how you would perform something. Where we have the BVX2 file export, which is also standard for all major software packages. But BTL, the machine also will take BTL, the Cambium software.
Maybe also for us, from a user's point of view, we use BTL files on some machines and BVX and BVN files on the Hundegger machines. And, BVX, BVN, this was made from Hundegger for Hundegger. These files were made for one specific machine. And it's been tested and whatnot, versus a BTL, that's a very generic language that works for, I'm just throwing out a number, probably between 50 and 100 machines. And so if you're just doing a saw cut or something very simple, I think it really doesn't matter. But as it gets more involved or more complex, or if you're using, customized units like that multi-drill unit you saw, I think, like that's when it's much better to just go straight, using the Hundegger files. It's just that it's a lot more tested and more streamlined.
I think we continue with CLT because we have a few slides, as you can see here, and only 20 minutes left.
Okay,
so I will shift now to the CLT approach. These are typical pictures from German buildings, and that's the major difference. North America, CLT is mainly floor elements, where CLT in Germany is also very often wall elements, interior wall, exterior walls, which leads to different approach and demands for the machine. Cross sections, or let's say dimensions, are a little bit larger. North America, we go up to 3,660. And length up to 8 meters, where the standard maximum in Europe is 3.6 meters by 16 meters. This is due to regulations, traffic regulations, and most panels are even only 2.6 meters in height, because that's the floor height, and you can ship on a truck easily 2.7 meter. Then it becomes more expensive and difficult. So we keep it a little bit smaller than in North America. For panel processing, CLT panel processing, we have two nice machines available. We have the UFA and we have the PBA industry. The UFA is a machine more like a big, very big molder. You move the panel through the machine and we trim all the edges off. We already make a nice rebate or a lap joint if you require. And the UFA can also do maybe from the bottom side, we can already plunge out a service hole for ventilation, for sprinkler systems, whatever. Big advantage is you have not to turn the timber or the panel afterwards, because when we come then to the PBA is operating from the top, cutting, milling, everything done from the top. And this is almost by all CNC machines, even if they come from Germany or from Italy. So if you want to work on the bottom side of the panel, you have to move it out, turn it, come back again. By using the UFA, you are eliminating this problem because it's already performed. So both machines work together in a perfect way. If you have an UFA and a PBA, then you are top level, my opinion, regarding production possibilities. This is just a few of our customers. And this is then their setup, the minimum setup if you combine an UFA with an PBA. So you have the UFA is a flow machine, so the timber is moved through. Then it will be loaded to the PBA, processed, maybe window cuttings in Germany, or maybe some other openings for floor panels in North America, and then you take it out. And then you can see one UFA can even feed 2 PBAs. One UFA can even feed 3 PBAs. So we currently installed in the Binder factory in Burg-Bernheim one UFA that is feeding 3 PBA industry machines. And this is really an unbelievable setup from capacity-wise. So here you have a layout, where you can see the workflow of the material. So we go in left, and then we distribute it. And the nice thing that I will tell you at the end, all 3 machines are linked together. So a PBA 1 or PBA 2 already knows what has been performed by the UFA and is only processing the non-produced parts or options. So you're saving unbelievable time if we talk about floor elements, because floor elements, they have to be trimmed, they need maybe a rebate or a lap joint, and that's it. This is a real picture. This is Pfeiffer, company Pfeiffer. So from the left side, can you see my mouse, Stefan?
Yeah, I can see.
From the left side, the material will go through the UFA. Then it will go to a rest spot, because sometimes the glue has to cure. And there you take out material. You store it, the raw material, a little bit, because it depends on your gluing system beforehand. If you're doing now same sizes, double sizes, or whatever, and then you continue down the road to the PBA. So you need really good glasses if you're in this factory to see from the left to the right side. This is the view from the end of the line. So we have here the seam machine, where here within is a safe area, safe cell, where we do all the CNC operations. And here the panels come out and will be stored here. Honestly, I don't like this conveyor stuff. The reason is, if you cut out a bigger opening, it might fall down, except you don't finish the part 100%. And this is not my idea. After the CNC, the part should be ready, and then we have to move it out. So an overhead gantry crane, like they have here installed, is a big advantage, but at least you need two. You need one for loading and one for unloading. So processing CLT panels efficiently is money, because you have also to invest a lot of money in infrastructure. You cannot start in a small shed. You really need some space to do that. Here we have again the workflow in the UFA. We have loading, then we align the material here, go through the UFA and take it out. Unfortunately, the video is not working, but here you can see it again. On the left side, there is some equipment from a Slovenian company. They bring the material in, then it goes through the UFA. It goes out of the UFA, here in this way, goes down there. There will be then a sander. And this is the inside of the UFA. So we have here the panel you can see very well. On the right side, it's already trimmed. On the left side, you can still see, okay, this is the overlap from the gluing. So this machine will trim the panel to the right width. And also we do the initial cut at the face end side and the rear side. Because modern CLT factories, they glue to demand. They glue maybe with 2 centimeter overlap on both length side. And at the face end side, it's the same. So they do the nesting also previously, and they glue the master panel according to the nesting. So there is hardly anybody wasting more than maybe 5 centimeters of material on the edges, on both edges, because this is pure money. And then you can imagine you have in your panel, in a master panel, you have 3 different parts that are already nested in. And there are already systems that you have RFID chips or labels that are monitored. So you see exactly what will come to the UFA. You select the right nesting. This information will go back to the host computer, will be stored. And when this part comes then to the PBA, to the CNC machine, you only select the right nesting again, and the machine will carry out only the missing operations. So this would be the video. After we have finished, after we have passed the UFA, the panels are square. They are already the right size and maybe as much as pre-processed as possible. Afterwards, here again, this is the company Binder. They distribute the finished parts with an automatic gantry system with a big vacuum crane and distribute it to the different PBA machines, to the working tables, to the feeding tables. So this machine is completely encapsulated. It's working in a safe environment. There is sawdust extraction, everything in. On bottom side, we take out the waste. This would be a similar setup where we have a forklift loading. It's loaded in a table in front of the Hundegger working cell, I would call this, and it's feeded out at the rear end side, the finished part. So this is a Canadian installation here. You can see here very well the 2 CNC machines that's here in operation. And again, we see here the requirements, space requirement. You see we need, for a 16-meter panel, we need 62 meters. So it's some space required. You can start with this setup. So for instance, you start loading here, feeding in, processing, taking out. And later on, you build an UFA in front of that. So the combination or the setup of your factory also depends on your possibilities, on your budget, on the building that is available. We can also squeeze our materials sometimes in an existing building, this for sure, because that's much cheaper than a greenfield project. And this is, let's say, if you are a medium-sized company, then it's a little bit more effort in planning to find a nice workflow, but you save a lot of money by not building a complete new building. That's the topic, because when you talk about a greenfield project, the biggest ones in Germany or in Austria, we talk about 80 million euros for a complete CLT factory, from lamellas in to finished product out. And this is a lot of money. But you can even start smaller, just with the CNC machine, if you have a supplier for the panels. So this is the PBA industry. It's a massive machine, weight about 40 tons, but it's also a very quick, efficient machine. We have inside 2 spindles with more than 60 kilowatts. They can be equipped with different tools, and the tools, they come from a tool changer that can hold up to 36 different tools, even deep drill units. They can have slotting units, they can have cutter heads, finger mills, drills, whatever you require. It's full automated control, and there's no access for the operator. Yeah, there was another nice video where we have a black screen now. And so after the CNC process, where we carry out all openings, service lines, windows, whatever you like to do, we feed the material out from the resting table, so the part is ready. And you can see here very good, here's the remaining part, a very big block. So there are two possibilities. You lift this small block, the block onto the panel and feed it out, or you chip it with the machine, which is a lot of time and dirt. So it really depends on your workflow, how you do it, because you see on the working table, there's some space. So the big block, it might be taken out because there are rollers. If you leave a small timber spot on the big panel. So it depends sometimes a little bit about your workflow, how you take out the big offcuts, the big waste. But this is more a topic for walls than for floors. And floors, we have hardly these openings or these parts that could block the outfeed. So here we have then the outfeed area. The panel will come out from this red impact gate that will open, and the panel will come out. And again, we have a big vacuum crane that will then pick up the panel and make a pile and sort it however you like it. But what's this? We have here some pipes. The reason is, machines is only one part. The big part in CLT these days is the workflow. You have not time to lose time, because you can imagine, you bring in a panel, you fix it, you process it, you have to bring it out. And this time, the feeding time, the fixing time, the unloading time, this is a huge portion. So when you have finished the part, there will be a lot of dirt on top of the part. So we decided to have a system. When the gate is open, the panel will move out, this suction bar will come down and will clean the panel surface. So you don't spread out all the dust, the sawdust shavings in the production hall. You keep it on the panel up to this suction bar, and then you take it away. So you have a clean panel after the CNC, which is important. And you have not to do that manually, and other things is done automatically here. This is one big point. One part is CNC and one part is workflow, very important. Here you can see some pictures then after the machine, where they then pile up the machine, different approaches, long roller conveyors. It always depends on the factory layout, on the approach. You still see people there. There will be some manual work on that, maybe some, let's say, fine finish, depending on what your customers expecting. Different kind of vacuum crane. It really depends what is available and demanded. These types of panels everybody would like to produce because they are straight, hardly any cutouts. These are floor openings or floor panels, sorry. And these kind of panels nobody would like to produce because they are from architectural buildings. You have a lot of component cuts, double cuts. You have millings for service lines in there. So left is the nightmare, and on the right side, this is what the people want to produce on the production floor. Yeah, this is a typical German wall element. So you can imagine how long it takes to make all the drill holes. And this is CNC time, where you could already produce a very nice floor during that time. So the calculation is always, how do they calculate the price? Some people only mention, this is by cubics. But I think cubics is the wrong attempt to do that. I would do it by square meters plus add-ons for special operations. Otherwise, it's very difficult to find the right price for cutting these panels. Okay, this was about the hardware, what is state of the art. And 2 minutes left I think I have to speak a little bit about Cambium. Cambium is the software that controls all our machines. And this is a unique platform because it can link different machines together, which we already mentioned. Because usually it's like when you have a CAD system and you want to go to a machine, you have different steps, what you have to do. You have to optimize, you have to order, you need a post processor, you need a CAM module, you need a simulation, and then you go to a PLC CNC. If I have a Hundegger, in the Hundegger world, we made it a little bit easier. You have your CAD system, like the software we spoke before. You have your export file, and then you end up in Cambium. All the information that is available is also available in Cambium, and we can even bring information back for ordering processes, for nesting, for IC control, so we can even generate events. And if it's only, let's say, a message on a smartphone, which gives you the progress of your project. So all these things are possible with the Cambium software because it's running on all machines, it's running on the host system, and it's a dynamic system where you have an interchange with all attached systems. So this is the idea how such a system could work. And the big advantage is it's only one software running there, Cambium. It's always the same. So if you can operate a K2, after one day you can operate a PBA industry or a PBA. This is not a topic. Yeah, and at the end of the presentation, I would have had some videos again, but even time is fleeting and I'm waiting for your questions. And if you like, I can even show maybe some more pictures if there are specific questions, because we could not see the videos.
Hi, thank you, Wolfgang. These are great resources, and I hope what we can do is edit this video, then work with you to provide an online resources to links to all the videos. Yep. And essentially, to help the flow of your information and what you're doing and bring that obviously to the English-speaking audience, and make it as widely available as possible, because it's a lot of information, and you can see from the questions to keep up. It would be great to have these online resources.
Yep.
Stefan, can you read through the questions? I think it's best if you do that.
Sure, yeah. One question is, when did Hundegger start building gantry centers skewed for mass timber panels? This is a substantial leap from K2 in the beam dressing machines. So that's not that new, but maybe I'll let you talk real quick, Wolfgang.
How we start with the PBA, we started with the SIP panels originally, and then very soon we ended up for glue lamps, beams. That's about, also 20 years ago. And then it was very quickly, then it showed up company Sandner, which was the pioneer before Binder. Sandner had the panels with 1.25 meters. The 4 feet panel came from Sandner. Later on, it was Binder. Then some people started larger panels, CLT panels. There was Stora, very early company. There was people like KLH, companies looking for larger machine. And so the PBA, the gantry machine for CLT panels, developed. And the first industrial approach for us was then the Stora guys. And so far, we are now establishing, or let's say, will be the equipment supplier for factory in Czech Republic for Stora, and also for Binder. So we are very close to these guys. And these days in Central Europe, I say 95% are sawmills of big CLT suppliers.
Okay, yeah. So I got a bunch more questions. I'll just go through them fast. Can you create concealed slots that are concealed on all faces of the timber elements except one? So I guess what they're looking is like hidden end crane slots for knife blades and whatnot.
I didn't catch it. What is with the knife plates, Stefan?
They're asking if we can do slots on all faces of the wood. I guess I can answer that real quick. The answer is yes, but it would have to be with that chain slot cutter, the one that turns, the one that you saw in the photos.
We can also do it the circular blade, this is possible. We can do it on operator and fence side also. It depends only how big the timber is or how wide the timber is. So we have customers, when they do a pre-slotting, they use the big saw, the big saw blade to do that. Just a moment. I just shared a folder. I have plenty of pictures of these things. Just a moment. Here we go.
I guess one of the things too, you always have to picture, I mean, essentially it's either that chainsaw or it's a saw blade. And if it's a saw blade, you can't do a rectangular hole, sort of like hole blind. So you make a through slot, but it wouldn't be hitting on the face. Wolfgang, that's something that happens here a lot with like post and column bases, where you would have a knife blade at the beam end at the end crane.
This is the topic how you perform that, because we have customers when they make face end cuts, they even glue something in to hide the rounding, because you can do something. You talk about something like this, I think, Stefan, that you have a blind slot here. You see that?
I see 1,000 pictures, not the one particular one. I think we still got a little bit of a lag.
You see this picture now?
There we go. Yeah, we got those now. Yeah, so, and I don't know, maybe I didn't understand the question, right? But yeah, essentially, if those would be posts or columns, but often, you wouldn't have that slot on the side face, so you would have to really only at the end crane. And here that also has to do with fire protection. Everything has to be fully concealed. But yeah, that makes sense. What he's saying, like, just make a nice slot with the saw blade, because it's a lot more accurate and quicker probably too. And then just glue in a filler piece for that purpose. Okay. I hope that answers the question. And if not, like, I mean, like, you can always reach out to Greg or me, and we'll answer what we can, or we can forward that to Wolfgang for a more accurate or a more detailed answer. Another question: could this robot concept be modified so that it could work on an edge of wider panels or vertical panels? I'm not sure if I understand that question right, but mostly those machines are designed that the parts would run through flat, so not on an edge.
So we are currently working on. So we are limited with the robot currently on a height of 300, but there is the demand from a continent west of Europe to have even columns sometimes with 500 or 600 millimeters. And we do a design study currently even to pimp up the robot for larger cross sections.
Yeah, I think that's absolutely going to happen. As we go taller with those buildings, the columns will become bigger and bigger. So I think even 500 or 600. I mean, we've seen stuff that is bigger than that. Well, what else do we have for question? Max hole depth of the long drilling unit that you showed us. I think you say 1250, and then that's 48 inch. Is that correct? 1250 millimeter for the long drill unit.
Pardon? How many millimeters?
I think you say 1250 millimeters for the long drill unit, the special one that you showed us. Is that correct?
Yep.
So that would be 48
any angle.
inch.
It can go in any angle. It's 4 feet almost. Yeah. Yeah,
and then what about diameters? What's the smallest that you can still do, and what's the biggest?
So we have had Japanese clients. They used it really for drilling 1 meter or even more in, let's say, in a 45-degree angle through the timber. This was their aim to achieve that, to put in their special steel rods for special truss connection.
Yeah. Okay. Yeah.
But it's always then a topic where you go in and where you go out.
Yeah. There's another good question. Is the trend towards composite woods with connectors of other materials what you see from your customers? Don't know if you understand that, but it's kind of, like probably like the stuff you showed us with the Baubuche, if you see big trends with that, with like steel and wood connectors combined. And then composite woods, I would assume that's is referring to engineered wood products. Please type if that's not what you meant, but kind of what's your experience or your trends in Europe that you're seeing?
Also Baubuche is for sure used if there is a need to have the strength, if there is the architectural reason, and even if you have to achieve certain spans, because Baubuche is even not cheap. But you have this GL80, which is very strong, but then they combine, even if you have seen the traditional joinery with the metal plate or with the metal connectors, and they are doing trusses. This is the idea. It's not a full beam like we have here. You can see this picture here with the big softwood beam. It's then more trusses what they're doing.
Okay. So I guess the long and short is that there is a trend, but it's still fairly expensive, and it only makes sense in certain applications. Okay, I still have another, 20 questions here. Design software compatible with CNC machines. I think that's been answered. It's basically HSB CAD, CADWork, Dietrix, CMA in Europe. I don't know, did I miss anything else? That is, those are the major ones, but I'm sure there's other smaller softwares that would write those files.
Yeah, I think this is always the topic. If you go for this very highlighted projects, then it's very often unique projects where you even have then very special machines where the price of the product is not the topic. I think to be successful working with timber, you also have to be very price conscious and efficient. So if you can use your repeating details, as this company I showed, production building, they are doing always the similar trusses. They have the same connection using, so the processes are streamlined, and they say, okay, depending on the span that we have a 20 meter, 25, 30 meters, we adjust the cross sections. And from a certain point, we are not, let's say, competitive anymore. Then somebody needs to love timber to build in wood. So I think that's the part which is even then in the office in the very early stage, in the design stage.
Mm-hmm. That kind of leads to one more question that I actually think that's a really good question. We get that all the time too, and we do, I feel, a lot of education with our customers, but it's like, what's the best way for a designer engineer to learn which cuts are feasible and what the limitations are for various CNC machines, so we can avoid specifying something inefficient or impossible to build? I think that would be great at some point if there would be almost like a handbook, like fabrication detailing handbook, what can be done. But it's also very difficult because every machine is unique. But I don't know if you from Hundegger, if you have something like basically all the processes that the machines can do, sort of kind of like, well, pick one of those,
So if there are special projects coming, we know that sometimes in a very early stage, because we have our own application department, where then very smart guys ask very strange questions. If we can do that, if they can do it that way. And then we work sometimes with them on a solution. I think this is the know-how and the advantage of the established companies. They have the experience what is possible and how to design machine-friendly, because you can only be cost efficient if you can do it efficiently on the machine. Because if you do, I mentioned we can do 95% of all operations very efficient, very quick. 3%, this we still can do, but that takes time and that takes money. So if you can reduce that down to the 95, you will be successful. And this is still, this know-how is still, let's say, the factor for a company to be successful, to be competitive, to be a little bit ahead. Stefan, you might know Neue Holzbau AG, for instance, in Switzerland.
Yeah.
They are ahead because they do engineering. I would assume 40% of their work is engineering and 60% maximum is processing timber.
Mm-hmm.
Yeah,
I think we will see that more here and here too. And meanwhile, I always encourage, design teams to talk to us early on. Like, don't specify everything. Give us a call. It's like, hey, I have this in mind. Does that make sense? And then maybe just a big rule of thumb is like, picture sort of what kind of tools are available. It's like, well, we have drills, we have saw blades, we have router bits, essentially mill heads, and if like kind of like what kind of a tool could we use to make that type connection? And if you think there is no tool or I wouldn't know how to do that, then that's probably not a very good connection. And then there's all the specifications, like how deep can we really drill, how deep can we drill accurately, and all that stuff. But I think that's something that then needs to be discussed with the fabricator. And we have those conversations with the engineers we work with all the time, and they kind of, after a while, pretty quickly they realize that what can be done and what not. And again, it depends on what kind of a machine and tooling people use.
Just one topic. And this is, again, a strength of Hundegger, because this Cambium software, what I was mentioning, is even programmed in-house. We have 30 software guys in-house doing our software, the hardware control plus the interface. And the big advantage is, if you do your design in the office and you export it to the Hundegger file, you see immediately if it's wrong or not. And even in the simulation, which is in the Cambium much more detailed than on the other machines, you can even then see, okay, it's specifically this strategy I would like to do. Okay, you can get lost in details. And for that reason, you can even set your defaults. As I mentioned before, you can make a default for nice timber frame buildings, visible appearance, where you want to go with a specific router. For other projects, you have your quick strategy where you don't care. You let the machine decide what is best and most efficient. So these are the parameters or the screws where you get your money from, is just to see, okay, how quick can I get from the CAD to the CAM? And this is where I see a bigger advantage at Hundegger, because we deliver the whole package, not only the machines, the machines and the software together. And otherwise, the machines are only blue steel with some motors and drilling and whatever, but the control is the key.
Wolfgang, I have a question that we have many more technical questions. I don't know if we'll get through them all, but I would like to ask, we were talking earlier, the demand is so big for mass timber. If someone wants to build a factory in a booming market like the US, the orders you have just to get machines. Can you talk about that challenge right now?
The challenge for Hundegger.
Yeah, like someone calls you up and says, all right, I want to build the biggest and best factory in the world, and I just raised 100 million from a venture capitalist. How many machines can you deliver to me, and how quickly?
That's a tricky question.
Yeah,
although there is COVID, everybody wants to build in timber. Wooden structures are sexy in Europe. So lead times is for sure an interesting topic. And this has then really to be discussed with each customer, but we are talking not about months, we talk about more than 12 months currently for the bigger machines. The bigger the machines, the more lead time we have, because these are then bigger projects. They have a long perspective. You need a building, you need people, and on the short run, a robot drive, this is easier than a very big K2 machine.
well, this is a good problem. I hope the Hundegger team doesn't work too much, but that you produce as many machines as fast as possible. But the other thing is, as you said, in a market like the US, it has potential to become the biggest market for mass timber, because we build so much with wood, and there's an extreme boom here, but we're already supply constrained. what do you think could happen in a big market like the US? Where is the potential for growth, and what do we need to do to make it happen faster?
I think the big issue in North America is the structure of the companies. In Central Europe, if it doesn't matter if it's in Italy, Germany, Austria, it's very often family-owned companies with a long history. They invest all the money in the company. They are proud about their company. North America, we also have these family companies, and I really appreciate them. The other way around, we have this big invests, a lot of money, they pumping up the money like crazy, buying machines, building factories, no clue about workflow, no clue about wooden structures. They buy big architectural companies, they hire very famous people. But by the end of the day, you have to make money, in my opinion. And this is only possible if you balance your investment versus your return, because it's still competitive. And this is where I think North America will grow. And this is by the young people or by the new professionals. They're willing to learn what is the best, let's say, fit for purpose. I like this word because it does not make sense to have a rocket-sized factory and building 2x4 stick framing with that. You need the right machine for the right product and for the right market. And this is different between Europe and North America, and you cannot you can compare it, but it's different. The approach is different. We have a lot, as I mentioned, a lot of CLT, GLT, mass timber projects. They are only 3-story highs, or even they are for smaller business. Farm buildings are in CLT and glue length structures, and they are competitive price-wise. So this is where you have to end up. You have to see, okay, where's the market? Where can I make the money? Is my opinion. And last word, I think European players will step into that market in a big scale in North America, and they bring the expertise, the experience, and they even have now their distribution channels already established. So I don't see the North American sawmill, except a very few one in Canada. I would, and it starts with K and ends with Kalashnikov, who is for me an example who can make it right, or Freres. They source the timber and they have the resource available. And I think that's the key for the CLT factories.
No, thank you for that, because there's all this growing interest, including from investors. But if you're taking Silicon Valley venture capital, they're looking at it from a software industry, and they're saying, well, we want to scale 10 homes the first year, 100,000, 10,000, then 100,000 buildings with 30% profit margin. And they can throw a lot of money at it, buy a lot of machines, but they don't have any of the people who know how to build one building profitably. So how do we get more, let's call it investment capital, that's doesn't require typical venture capital returns, but does offer returns? And what I mean is bank loans and investors and people that are looking for the kinds of returns you can typically get in real estate in the US, which is right now like 5 or 6 or 7% as a real estate investor. So I think the biggest growth is getting that kind of capital involved to support the growth of the factories and working together on real estate developments. I think that's realistic growth, but that's just my opinion. The potential is there. I mean, think how many, if you were just going to guess, Stefan and Wolfgang, just this, how many factories could the US market support that have Hundegger machines in them? I mean, what I mean is, think the number, like how many Hundegger machines has Hundegger already sold, and how many of those are in Europe compared to how many are in America?
Also, from the whole history, I would say less than 5% of the machines are in North America, if I count all together.
Yeah, and Stefan, chime in on this too, because I mean, we talk and we look at Oregon and Washington. I actually think there's room for literally hundreds of companies that are using machines like Hundegger's to make prefab buildings. We have such a big market for wooden homes, and this manufacturing is so efficient, but we currently have very few of these manufacturing facilities, so we're supply constrained. So how do we get there to take this opportunity? Stefan, you have an opinion on this, I know. So what's your take?
Yeah, I'm trying to give you a good answer. I think you have to kind of differentiate, in my opinion, between highly industrial setups, like, I mean, the stuff we just seen here with multiple gantry machines, you know, like the $20 million to $100 million plus, you know, setups. That's one thing. And then, you know, I mean, Hundegger also sells smaller machines for a lot less money. And then there's, you know, there's more like industrial factory setups. And then there's a lot of, I mean, the US actually have quite a bit of timber framing companies that traditionally used a lot of Hundegger equipment for highly customized stuff. So that's different. But if I compare that compared to Europe, where I was, like Germany, France, Italy, you know, like Switzerland, there's almost in every village, there's a CNC machine for wood processing, and that's certainly not the case in the US. So I would say based on that, that's a very different, I mean, we have a lot of potential here. Hundegger has a lot of potential in that market. We're also working, I think it's, even with those very few machines, it's still highly competitive. And I think we're competing against other machine owners, but we're mostly competing against other industries and against other approaches. You know, I mean, most homes in the US are still stick frame homes that are built on site. And that's maybe changing. And then I think then that this demand will explode if that's the case.
Well, all right, Wolfgang, we're already an hour and 20 minutes. I don't know if you have time for more questions, but my goal is I'll post these your video, we'll edit a little bit so it flows, but then hopefully we can move these kind of technical questions into an online discussion group. So when the questions are answered, anyone can come and read them publicly. So we're sharing the information more. That's kind of my goal. Do you have any time for more questions?
Yeah, if you have some questions, I think I will get dinner a little bit later today. Not a problem.
Stefan, you want to read a few more?
So one burning question was on, actually, I think that you kind of have to say that since you teased us with the photo, but they want to know what kind of approach. It looks like that's a moment frame that you currently have on your screen with those steel plates, and kind of what type of a building is that? Who is it for, and who made it? I mean, that looks really cool.
That will be
a farm building. Yeah. Wow. Yeah, it's amazing. Yeah, it's really cool.
And you see here this is a company very close to us. They do. You see now the picture with the dovetail mortise. Mm-hmm. Yeah. So they do different kind of structures, but they even are very progressive. You see, they're even building concrete frame and a wooden roof, because they do it. They even make steel columns if you need. So they really say, okay, we use the best material, because you see now the picture with this big truss. This is a 40-meter span, and to use a wooden column here would be a fortune. And to have a beam like this in timber to get the stiffness, this would be even very expensive and difficult. So they use the material that fits best.
Yeah, we see some of that here a little bit too. Adidas headquarter by Levera was sort of done like that. It was like precast concrete modules, and then a lot of timber beams and CLTs. So we see that too, and I agree that makes sense. Use the best material for the best purpose and keep the wood where it makes most sense.
And this was the reason why I mentioned Mars timber, a little bit religion, because sometimes people, when they are too religious, they only go like this. And I think in timber, you have to go like this. You have to see, okay, fit best to my timber. Where's the best use?
Yeah. So a few other things, a question came up with Revit. I mean, as you know, Revit is an Autodesk product, very common here in North America. Yep. Is there any way to interface directly with Revit onto your machines? What's your thoughts there? I certainly have opinions with that. But
I think you go via CAD work or you go via HSB card. I think that's the two ways you can do
so
it.
Somebody working for one of those software companies for years, I can say that there is no Revit. I mean, there are certain plugins now, I think, coming to the market that would do that. But in general, Revit is a design tool and now the fabrication tool. And so people import that using IFC files, SAT files. They bring in geometry to a more technical fabrication CAD, something like HSB CAD or CAD work. And then from there, they would send it to the Hundegger machines or any other machines in form of a BVX or a BVN or BTL. What other questions do we have? Yeah, I think on the question end, we're pretty much, I hope I didn't miss anything. If I missed anything, I'm sorry, that wasn't the intent. I have another question. Is there a need for portable CNC that can be brought to the job site to machine beam end connections? I mean, I guess if you want to bring 50 tons of steel and wires and stuff, but kidding besides, I don't know. I don't think Hundegger is making any effort towards that, but I mean, that would certainly be an interesting thought. What's your thought there, Wolfgang? Anything for a portable little
to bring
Hundegger?
the machine to the site?
Yeah.
Not a good idea.
And why?
Accuracy. You have to install the machine probably that you get a good product. So if you see the picture in the background where you see that with the braces where they have the brace in.
Mm-hmm.
So the topic is on-site construction. We have maybe the muffle, but for the off-site, then we take the Hundegger.
Yeah. And I may want to add to, I mean, if I look back for the last 20 years or so, like kind of the development of those machines, and correct me if I'm wrong or if you want to add to that, but if you look at those machines, the one thing, even as a non-professional, that just sticks out right away is like every year those machines get bigger, more powerful, heavier, and more expensive. So there was the trend wasn't towards a less expensive, lighter weight, easier to set up type machine. It's really, and I don't think that was necessarily companies like Hundegger pushing us for that. I think this is mostly companies that had a Hundegger. It's like, well, that's great, but now we want a faster spindle. We want a bigger spindle. We want to have a bigger saw blade. And so the result of that is just like, I mean, you saw those photos, those machines are enormous now.
Yeah.
So yeah, I'm just checking the chat here too, if we have anything else. Greg, did you see anything that we haven't talked about?
No.
Actually, that's really a good question too. What about using CNC machines for assembly? You have any thoughts on that? And I guess we should specify what kind of assembly we're talking here.
So far we have not an additive machine, so where we put parts together. That might change in the future, but assembly of wall panels, okay, this is an issue that is okay, where you have standardized components in a controlled environment like Rundeck or Weinmann is doing that already for a long time. Now they're doing that with robots. The only question is how efficient is it to do it with robots, and if you again get value for money, because you spend a lot of money to invest in such automated systems, and the question is if you get that back from a 2x4 or 2x6 wall, because there's not too much value adding on this process. To have robotic assistance at site or automated, I can only think about maybe in the sci-fi with an exoskeleton that will help you to lift easier heavy weights. But at sites, you always will need your cranes. You will need skilled people, skilled foremen. This is still an art of human, because this is the reason why we have hands-on mentality is needed for such structures, in my opinion. You cannot automate that, except you would standardize it to the last extent.
Well, there's other things too where I actually absolutely could see that. I mean, we spent weeks and weeks like screwing in timber screws for connectors like knap and connectors and rotoblasts and pit saws and all that stuff. So I could see that, you know, if one would do enough, again, it boils down to money, but if one would do enough volume of that, I could see that, you know, it probably wouldn't be that hard for a machine to mount one of those things, I would think, no? You know what kind of connectors I'm talking about, right?
Yeah, but you would not do that you would do that in a factory, maybe as something to screw in. If you do a series like in this Brock's Common system where they had always the same post, there it might be useful to teach a robot doing that process because it's a repeating process. But you know that by yourself, you run a robot in your workshop. It's always an issue about how easy is it to teach the robot doing that. Or two robots, you need one or three to load, to fix, to screw, to take it away. That's 3-4 steps where you need different robots or different aggregates on the robot.
Yeah, you could have different hands mounting, but yeah, that's certainly not that easy. I could see, I mean, it also, I guess, depends how difficult it is to find people and how expensive those people are, right? In the end, it's a money question. Is a robot going to be faster and cheaper than a human being? And if it is, I think we'll see that. So yeah, I think that sums it up. But I guess the long, you know, the short answer to that is currently there really isn't that much that is, you know, like kind of assembly that is automated other than for regular stick frame wall panels. And even there, that's you know, there isn't that. That's not very common, I would say. That it's available, but not that common yet.
Yeah, I think we could. That's been quite a few questions, and we're at an hour and a half. But I would kind of like to close with asking Wolfgang, if people want to get a hold of you or they want to follow up with you, what do you recommend they do to contact you if they're interested in buying some Hundeggers?
Send me an email and with a date for an appointment, and we can do a Teams meeting or whatever. Please be aware we have a small time shift to the West Coast, but if you would send me an email, that would be really appreciated, and then we can make an appointment and discuss further in detail.
Good. And the second thing is, this is kind of in our business interest, but I do hope more information like you shared becomes available in English that helps explain to people what Hundegger is and can do. And my kind of dream is that let's call it a center of excellence and or research in mass timber does emerge in the US. And of course, we'd like that to be in Oregon on the West Coast, but where all of this information and the best machines and market come to the US market faster. And here on the West Coast, we have so much wood and we have so much demand for housing, and the tech companies are here and they're becoming really, really big customers. And we're just like, wow, how do we make this happen faster? And how do we grow the supply chain? And how do we advance the industry here?
Yeah.
In partnership with other countries, because it's more mature and larger in Germany, Austria, and Switzerland.
No, for sure. This is North America is one of the most interesting markets from the potential from houses built from timber and coming projects. And I think it's even in Europe, it's the trend with, I would call it greenwashing. So you have to substitute your concrete foundations by timber to get a building permit in the future or something like that, which is strange because for some buildings, concrete is the better solution. But this is also something which is coming, the carbon stuff, and that you get credits for that building with timber, and even to get a building permit maybe in some areas will be very interesting in the future.
Okay, well, no, thank you for your time.